Today's lesson is on multiplying matrices. I typically start this lesson by telling students that if you can pat your head and rub your tummy at the same time, then you can multiply matrices. I'll pause for just a moment while you try that. Remember, it's pat your head, rub your tummy. You don't want to rub your head and pat your tummy because that will mess up your head. Okay, what makes that particular activity just slightly challenging is the fact that your hands are doing different things. And we're going to find that is the case when we multiply matrices. But if we practice, we'll be able to do it. So in order to multiply matrices, for example, two matrices A times B, the number of columns of that first matrix must be equal to the number of rows in the second matrix. And the order does matter. So we're going to get into all this in just a minute. If the product is defined, that means if I'm able to do that multiplication, if the columns in A are the same as the rows in B, if I can do that multiplying, then that solution matrix or the product matrix is going to have the same number of rows as your first matrix, and it's going to have the same number of columns as the second matrix. Okay, so let's look at just some examples of that part. It's called dimension analysis. Dimension analysis, where I analyze, let me write it down, the dimensions of the matrices to determine, one, can the multiplication take place, and two, what would be the result of the product? What dimensions would the result have? This is a very important first step to take. So in example 1, matrix A is a 3 by 2 matrix. I don't even have the matrix, I just know the dimensions. And again, a reminder from the previous lesson, this is rows by columns. And then matrix B is 4 rows and 3 columns. So the question is, can I multiply it? Well, I have a 3 by 2 times a 4 by 3. Now, these are the columns of the first matrix, and these are the rows of the second one. Since the columns of matrix A are not the same number as the rows of B, then this operation cannot be performed. So we're going to say that this product is undefined, and we want to be very specific. The reason it's different from yesterday or the previous lesson when you couldn't add, they had to have the same exact dimensions to add. This reason is different, so I'm going to be looking at your wording very carefully. Undefined since the columns of A do not equal the rows of B. And I wrote that a little bit shorthand, but I was still very specific. And remember, I'm not sure I even mentioned this yesterday, when writing a matrix, the name of a matrix, we use capital letters. Okay, so now we're going to turn it around, and we're going to say, okay, if I can't multiply A times B, would it still be possible to multiply B times A? So let's check that out. If the B matrix was coming first, 4 by 3, and then the A matrix, I'm going to multiply B times A, 3 by 2. Is that possible? And in fact, we find that it is, because the columns of the first matrix are the same number as the rows of the second matrix. Okay, they're both 3. So when I set them up in the correct order, and I see that these are the same, the rows by columns, right? Rows by columns. The columns of the first is the same as the rows of the second. Then I know that I can multiply it. Well, since the product is defined, I'm supposed to give the dimensions of the result. So this tells me I can multiply it, and these outside numbers tell me what the answer is what form the answer will have, the order or the dimensions. So the product is a 4 by 2. The product is going to be a 4 by 2 matrix. Okay? Let's do that some more. I'm going to continue with the red. Here we have 2 more examples, a 3 by 3 and a 3 by 2. So if A is coming first, multiplying A times B, is that possible? Yes, it is, because the columns of the first matrix are the same as the rows of the second, just in terms of how many entries. And since I can multiply, then the product is going to be a 3 by 2 in terms of the dimensions. And again, I looked at those numbers on the very outside, the rows of the first, the columns of the second one. All right, let's turn it around. How about B times A? Can I multiply a 3 by 2, that's B, times a 3 by 3? And that's going to be a no. That's a no-go, right? The reason is this product is undefined, or this time I'll just say no, I can't do it, since, now I'm going to be very specific, the columns of which matrix? It's the columns of whoever comes first. So in this case, BA, the columns of B are not the same as the rows of A. Okay, so be careful. Up here in our notes, we were multiplying A times B, right? To multiply A times B. And we write it like that. In this example, though, we have BA. So we're always looking at the columns of the first one, the rows of the second one. And if those are not the same, then you would not be able to multiply. Okay, so now we've talked about what do we need to be able to multiply. Let's go ahead and show you how to actually multiply. And we're going to start in the same place. We're going to always begin with dimension analysis. You'll get good at this pretty quick if you practice. You have to practice. Let me turn on some light. I'll just turn that off. You do have to practice, but once you practice, you should get pretty good at it. Sorry, I was doing autofocus. All right. So we begin with dimension analysis. We've got a 3 by 2 matrix, and we're going to multiply it times a 2 by 2. Can we perform this operation? Yes, we can multiply A times B, right? They ask us to do A times B. And the result is going to be a 3 by 2. Okay? So the first thing I'm going to do is I'm going to set it up very carefully. I'm actually going to set up, and I'm going to take several steps on this first one, but the further we get, the less work we'll have to show. We still just want to be really careful. Throughout matrices, there's a lot of multiplying and adding going on, and it's just too easy to make a mistake. So we want to go very carefully. Okay, so the next thing I'm going to do, I found out that I can multiply. I'm going to get a 3 by 2 product. I set that up. I'm going to actually label the position of my entries. This is row 1, column 1, and this will be row 1, column 2, right? The position of that entry. Row 2, column 1, row 2, column 2. And then we have row 3, column 1, row 3, column 2. Okay, now the location or the position is actually a set of directions to me. Row 1, column 1 means I'm going to multiply the rows. Let me write this over here. Row 1, column 1 means rows of A times the columns of B. And this is just based on whoever comes first, row A or B. Okay, so the rows of the first one times the columns of the second one. And here's how I want you to do it. We're going to use our fingers. When's the last time your math teacher told you to use your fingers for your math? Not very often, but I'm very serious about this. I want to see you using fingers. A lot of times students are not getting the right answer. I'll say, well, show me what you're doing. And either first they're not using their fingers at all. That's a mistake. Or when I see them use their fingers, they're doing it the wrong way. I can see that they're doing it the incorrect way. Remember when I said if you can pat your head and rub your tummy? Well, what we're doing is we're going across the row on the left hand. Row, across the row, across the row. And then with the right hand, we're going down the column and down the column. So while I'm going left to right on my left hand, I'm going top to bottom on my right hand. And that's that feeling of my hands aren't doing the same thing. Okay, so let's do this very carefully. I put my finger on the first entry in the row and the first entry in the column, the upper left corner for both of them, right? And then I multiply the first in the row times the first in the column plus the second in the row times the second in the column. So the first ones, and then I move, and then the second ones. Okay, I'm going to write this out on the side very clearly. We won't do this every time, but I want you to be able to see where it came from. So we did 6 times negative 1 plus 2 times 5. 6 times negative 1 plus 2 times 5. All right, so that's going to be negative 6 plus 10. And I'm not even going to add that right now because I want to concentrate only on my multiplying. I want to multiply, 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 then go back and add or subtract, add or subtract. It'll keep my mistakes down, reduce my errors. Okay, so this is row 1, column 2. I put my fingers on row 1. We're going to write this out. And my finger on column 2. Right, I'm starting with a different column because of the position that I'm in. So the first in the row times the first in the column plus the second in the row times the second in the column. You literally have to pick up and move your fingers. You have to move those fingers left to right, top to bottom. So we have 6 times 2 plus 2 times negative 2. All right, that's 12 minus 4. 12 plus negative 4. Okay, so row 2, column 1. I'm going to spread this out just a little bit for you guys. I'm hoping you'll be able to see better. Okay, row 3, column 1. Row 3, column 2. All right, so row 2, put my finger on row 2 at the beginning. Put my finger at the beginning of column 1. The first in the row times the first in the column plus the second in the row times the second in the column. So we have negative 1 times negative 1 plus 3 times 5. I'm trying to do too much. I apologize. Trying to do too much here and not writing what I mean to write. Okay. So when we go back, we're going to get 1 plus 15. Okay, so I'm going to pick it up a little bit here. Row 2, column 2. The first in the row times the first in the column, that's going to be negative 2. And then plus the second in the row times the second in the column. So that's actually negative 6. Okay, so I stopped writing over here and I'm just going to put the results. The first in the row, row 3, column 1. The first in the row times the first in the column. Remember, 0 times anything is 0. A lot of times students will mess that up. It's not because you don't know that anything times 0 is 0. It's because we tend to just ignore 0. When you're adding, you can ignore it. When you're multiplying, you cannot, right? That is definitely 0 and then minus 20. We should love it when we see 0 because the result is very, very easy. And then we have 0 plus 8. 0 plus 8. Okay, now for our final answer, we're going to go ahead and add or subtract, combining those like terms. So product AB is equal to 4, 8, 16, negative 8, negative 20, and 8. Okay, that's an interesting result. I just went through and I just added or subtracted in each location.